So this our drill is complete. Teachers and students have a great rest of your day.
All right. What would you guys like to see from the review? I will go over any questions you have in the time that we have remaining. What problems would you like to go over? Yes. Number 12, absolutely. 12 and 13?
Just 13.
Oh, just 13, got it. All right, so 11 through, I don't remember, like 19 or 11 through 20 are all stating the property that's being used. Number 13, we have the measurement of angle SIK. That's this piece right here. Plus the measurement of angle KIT. That's this piece right here. When I add those two together, it gives me angle SIT, which is this big angle right here. So that is my angle addition postulate. Angle addition postulate. What else would you guys like to see? Yes. Number 7? Absolutely. Number 7 says write 10 true statements from the picture below. Well, what's the first thing I can say based on the way that picture is drawn? B is the midpoint. Of segment AC. What do those little marks mean that are on there? Congruent. So I know that segment AB is congruent to segment BC. If the segments are congruent, what else do I know about those segments then? The measurements of them are equal. So the measurement of segment AB is equal to the measurement of segment BC. Whether I have a midpoint in the picture or not, when I have a segment that has that 3 points on there, what can I say? I'm thinking something similar to number 13 when we did that angle addition postulate. Do I have something similar? Yes. The length of AB plus the length of BC gives me the length of AC. Well, didn't we say up here in number 3 that AB and BC are the same size? So could I replace BC here? I could make another true statement that said that AB plus another AB is equal to AC. Or another way to write that exact same idea would be 2 multiplied by the length of AB, because I wrote it down twice, is equal to AC. Did I have to replace the BC? Could I have replaced the AB? What could I replace AB with? So I could say BC plus BC equals AC, or 2 times the length of BC is equal to AC. I want to use this idea right here in number 4. Could I use subtraction here instead of addition to make a true statement? What's the bigger segment? AC. AC minus, tell me something to take away from AC. or I could do it with BC. So I can do it both ways. If I have segment AB and I take away, sorry, I have AC and I take away AB, what would I have left? BC. What about if I had taken away BC? Then I would have AB left. For these last two statements, I'm using these ideas up here. If I know how big AB is, and I want to know how big AC is, I would take this length and double it to get the whole thing, right? Well, what about if I knew how big the big one was, and I wanted to know how big the little piece was? Would I still double the big piece to get the little piece? What would I need to do with that big piece if I wanted to know the size of the little one? Divide it by 2. So AB is half of AC. When I put the 1/2 out in front, that's exactly the same as dividing it by 2. Could I make another similar statement, but not about AB? What else is half of AC? BC is half of AC. We just said a lot from a picture that had 3 dots on it. What else would you guys like to see? Number 12, and which one? So 12 and 23. Let's go do 12 first because that's on the way to 23. Okay, so number 12, I start off with this idea right here. The measurement of the angles 1, 2, and 3, when I add them together, equals 180. And then they also tell me that angle 3 and angle 4 are the same size. So when I look over here, that looks just like my first equation, but instead of angle 3 that I had here first, now it's been replaced with angle 4. What are we using there? Substitution. Then you said 23, right? Okay. 23, next to last. Yep. For 11 through, I think it's 19, it's just what's the reason that you would use in a proof if you saw this? Yes. There will be some like that on the test, like what is it that we're using to say this? All right, 23. It tells me my first reason is because that's given, so I'm going to write all of my given information right here in this first box. Segment XY is congruent to segment WU, and segment XZ is congruent to segment ZU. I'm going to go mark that on my picture too. XY is congruent to WU, and XZ, this whole big long thing here, is congruent to ZU. Well, if I know that segments are congruent, because of the definition of congruent segments, what can I say about those segments? Yes. The length of XY is equal to the length of WU. They have the same measurements. The length of XZ is equal to the length of ZU. They have the same measurement. Step number 3 isn't using anything that I did in steps 1 or 2. I'm getting this from looking at the picture. Why would I be able to say that XZ, this whole big long segment over here, that length is equal to the length of xy plus the length of yz. Segment addition postulate. We can make the exact same statement over there about ZU being ZW plus WU. So I know that XZ is equal to XY plus YZ. Do I know that XZ is equal to anything else? It's equal to ZU, so I can replace this XZ right here with XY plus YZ. Could I do a similar replacement for ZU over here? What would I replace the ZU with? ZW plus WU. That's my substitution property. I substituted on both sides, but I replaced them with things of equal value. Before we make our next statement, I want to compare statements 4 and 6. I know from the reason column that I'm going to be using substitution again, but I'm not quite sure where. What's the same and what's different between 4 and 6? There's no XY. My ZW stayed. But there's no WU, right? When I look down in step 6, it still has YZ equals ZW. That stayed exactly the same. Well, how would I get rid of things? Subtraction is how I get rid of things. But am I allowed to subtract different things from both sides? No. If I'm going to subtract something from one side, I have to subtract the exact same thing from the other side. Are the letters XY exactly the same as WU? No. Well, if I'm going to take it away, it has to be identical. But what do we know about XY and WU? They equal each other. We know that from up here. So could I replace one of them with the other? Yep. So instead of XY, I could write down WU plus YZ equals ZW plus WU. We just use substitution to replace XY with WU. Now do I have the exact same thing on both sides that I could get rid of? Yes, I have WU here, and I have WU here. And what can I use to get rid of the exact same thing on both sides? Yes, subtraction, property of equality. So now I have that the measurement of segment YZ is exactly the same measurement as ZW. So why would I then be allowed to make this leap and say that means they have to be congruent? That is the definition of congruent segments, yes. '24, absolutely. Let's just roll on to the very next one. Back page, only thing on the back page. All right, so 2 is congruent to 3, I know that because they gave it to me. So why would I know that angle 1 and angle 2 are congruent? Vertical angle theorem. These are vertical angles here. So by my vertical angle theorem, I know they are congruent. Well, if 1 is congruent to 2 and 2 is congruent to 3, then does it make sense that 1 and 3 would have to be congruent, have to be the same? What could I use to say that? 1 is congruent to 2, 2 is congruent to 3. I so want to use substitution, it's not even funny, but there's a symbol up here that means I can't. Transitive property, yes. If you see the congruence symbol and you want to use substitution, you have to default to transitive property. Substitution only works with equal signs. How do I know that angles 3 and 4 are supplementary? What kind of angles are those? They're a linear pair. They share this side right here, so they're adjacent, and together they make this line, this straight angle. So if they're a linear pair, why do I know they're supplementary? So definition of linear pair, we actually just did. We didn't write it down, but definition of linear pair is like, aha, it's a linear pair. Linear pair theorem lets me say, once I know they're a linear pair, now I can say they're supplementary by the linear pair theorem. Well, if 1 is congruent to 3, and we know that 3 is supplementary to 4, then why could I say that 1 is congruent to 4? Could use transitive, or we could use substitution. I would accept either one here. I would probably veer towards substitution on this one. But I would accept transitive property here as well, yes. Number 20, absolutely. I like this one. Did I go too fast for anybody? Do you need me to go back to 24? Was a you write this entire thing yourself problem. First thing I'm going to write down as a statement is this piece of given information. Segment GH is congruent to segment JK. And my reason? Because it's given. If I know the segments are congruent, then what else can I say? They're equal to each other. Segment GH is equal to segment JK. Why would I be allowed to say that? That wasn't given to me. So close. We're not looking at angles here. Segments, yep. Definition of congruent segments. Do we know the measurement of segment GH? How big is it? 7x minus 32. So in the place of GH, I'm going to put 7x minus 32. Do we know the size of segment JK? 6x plus 26. So I'm going to put that in the place of segment JK. What did we just use to be able to make those replacements? Substitution. What are we supposed to prove?
X is equals 15.
X is equal to 58. So now I need to solve this for X. When I'm solving an equation, I always like to group my X's together first. I like to get them all together on one side first. What would I need to do to group the X's all on one side? Subtract 6x from both sides. So what would that give me on the left then if I subtracted 6x? 1x by itself? Minus 32. What would I have on the right side if I subtract 6x? 26. What did we just use to subtract 6x from both sides? Subtraction property of equality. What else would I need to do here to get x all by itself? Add 32 to both sides. So on the left, I would have just an x left. What would I have on the right? 58. What did we just use to be able to say that? The addition property of equality. What were we supposed to prove? X equals 58. I'm done. I didn't have to use up all my lines. What are you confused about? It is okay to have leftover lines. I can think of a way of doing this problem that would take up more lines. For example, if instead of subtracting 6x from both sides, you subtracted 7x from both sides, if you did that, you would end up with a negative 1 over on the left. And then I would have to divide by that negative 1. And then I'd have to flip it around the other way so that it looked exactly like what I was supposed to prove. That would take up some extra lines there. It is okay if you are filling out the entire proof to not use all the space they give you. If I give you a proof that's partially filled out and you see statements and reasons and those are filled in one or the other pretty much all the way to the end, then we're going to use up all those lines. But if it's just blank like this and you fill in all the pieces, it's okay to not use everything that you've got. We've got 5 minutes left. I have time for one more problem. What else would you guys like to see? You said 21? Absolutely. Using the figure to the right, if the measurement of angle LKJ, this guy right here, so the whole big angle, if that is 137 degrees, PKJ, this little guy down here, is x plus 5 degrees, and LKP, this one over here, is x plus 90 degrees. We're supposed to find x, and we're supposed to find LKP. What do we have to use to set this up? What theorem, postulate, or definition are we going to use to set this up? Angle addition postulate. So angle addition postulate tells me that the measurement of angle PKJ together with the measurement of angle LKP is equal to the measurement of angle LKJ. I know that PKJ is x plus 5. I know that LKP is x plus 90. And I know that LKJ is 137. So I would combine my like terms together. I would get 2x plus 95 equals 137. Then I would subtract 95 from both sides. What is 137 minus 95? 42. Then I divide both sides by 2, and I get that x is 21. Then to find LKP, that was x plus 90. So I would do 21 plus 90, which is 111 degrees. Why does x not have a degrees symbol on it? Is that a mistake that I made? Why does x not have degrees? It's part of an angle. It's not an angle all by itself. So x doesn't have degrees with it, but my angle, LKP, does. All right. I have office hours after school today. If you guys want to come, I'll be here until about 3 o'clock. You can stay and study with me. You can email me questions. The answer key for the entire review will be going up here in like 20 minutes. I'll do that during third period. That's when that answer key will go up. Best advice on how to study using your review is to work through the review, finish everything you can to the best of your ability, and then get in and correct it with the answer key, just like when we grade homework in class. Taking the time to write down those corrections will help it stick in your mind better than just looking at it, because you've got multiple modes of learning going on. You have eyes, you have movement, you're probably saying it to yourself in your head, so you're listening to that piece. You want to get as many types of reinforcing information in your mind as possible. Have a fantastic rest of your day. Please let me know if you need any help or any assistance.